For the last lesson in this unit on area, we're going to visit circles and sectors, which is just a part of a circle. So let's just start with circles, and let's give you the area formula right off the bat. To find the area of a circle, all we need to know is the radius. The area of a circle is pi times the radius squared. Pi r squared. That's how you find the area of a circle. To find the area of a sector of a circle, a sector, again, geometry, I like pictures. That helps explain what a sector is a part of a circle. In common language, think about a sector as a pizza slice. A sector is a pizza slice. If you want a more precise definition, then a sector is the area formed by an arc. Here's our arc. And the two radii at its endpoints. So draw a radius from this endpoint, draw a radius from that endpoint of our arc. And it's the area inside that figure. To find the area of a sector, what we're going to need to know is, first of all, what's the measure of the arc? We take the measure of the arc AB in our picture's case, and put it over 360. This part of the formula is essentially asking, what fraction of the circle am I talking about? And it would be the measure of this arc out of 360 degrees. And you take that fraction and multiply it by the area of our circle. Pi times the radius squared. So this piece tells us the area of the whole circle. This tells me what fraction of the circle I'm talking about. Just 120 degrees out of 360, just 90 degrees out of 360, etc. So there's our formulas for circle and the sector, and those are both on your nice formulas sheet down here at the bottom. Area of a circle, pi r squared. Area of a sector of a circle, just know they have this big N. Don't know why they chose N, but you just need to know that's the measure of the arc. Whatever the arc is of the sector, measure of the arc over 360 times pi times the radius squared. So let's do some examples. What's the area of the circular region on the wrestling mat? Round to the nearest unit. We've got a wrestling mat, it's a circle. This 32 is telling me the length of the diameter all the way across. My formula for the area of this is pi times the radius squared. So if I have a diameter of 32, then I have a radius of half of that. Radius is half the diameter. So cut 32 in half. I have a radius from the center to the side, 16. So the area of my mat is pi times 16 squared. 16 squared is 256. If it asked us to leave our answer in pi, then this would be our solution, 256 pi. However, it says round to the nearest unit, so multiply those together. If you do, rounding to the nearest unit means whole number, no decimal. 804, and we were measuring in feet, so feet squared. That's the area of our mat. If you flip to your very last page in your notes guide, we have another example. What's the area of sector GPH? So this shaded region in here. Leave your answer in terms of pi. So to find the area of a sector, what I need to know is the measure of my arc given to me is 72. Put the measure of your arc over 360 multiplied by the area of our circle, pi times the radius squared. My radius is 15, so pi times 15 squared. It says leave your answer in terms of pi, so we're not going to do anything with this pi, leave it put, just move it on down, and we will multiply everything else. So you can do 72 divided by 360, and then multiply that by 15 squared, which is 225. What you should end up getting is 45. And that's leaving our answer in terms of pi. 45 pi. We were measuring in centimeters, so centimeters squared. Alright, that's part one. Next, we're going to talk about something called a segment of a circle. Segment of a circle. So, I wish there were a shorter definition. But the segment of a circle, I like the picture again a lot better. This kind of shows you what it is it is part of a circle. It is bounded by an arc and the segment joining its endpoints. Put simply with our picture, if you just draw any chord in a circle, then the area formed by that chord and the arc, say something like that, we call it a segment. The segment of a circle. To find the area of a segment, what we're going to do is, imagine we draw a sector at the endpoints of our segment. We will find the area of the sector, which would be this entire pizza slice. Then we will subtract the area of the triangle. The triangle we have up here, that's just this white part. Right? So if I find the area of the whole sector, the whole pizza slice, and then I just subtract out the area of this triangle, what's left over is our segment. So that'll be the area of our segment. Take the area of the whole sector, subtract the area of the triangle, and what's left over is the area of that segment. Let's do it in a couple of examples. What's the area of the shaded segment shown at the right? So this little sliver. Round your answer to the nearest tenth. What I need to know is the area of the sector first. The area of my sector will be the measure of my arc, so let's go after that first. Since this angle in here is 60 degrees, then the measure of my arc is also 60 degrees. That's a central angle made with the center of my circle, the central angle, and the measure of the arc always the same, one and the same. So that's the measure of my arc, 60. Put that out of 360, then multiply by pi and my radius squared. My radius is 18, so 18 squared. And we'll leave it at that for now. What I then need to know is the area of my triangle. I'm going to take the area of my sector and then subtract the area of this triangle right here. What will be left over is the area of my segment. So I need to find the area of the triangle. The area of my triangle is going to be 1/2 base times the height. I have this side is 18. That'd be a good base. Then I just need to know the height. And if I draw a height into this triangle, make a right angle, what I've got in here is a special right triangle. This triangle right here is a 30, 60, 90 triangle. That can help me find the height. So let's draw it a little bit bigger over to the side. In here I'm drawing this triangle. We have a right angle because we drew an altitude or the height of our triangle. That's 60 degrees, so that's 30 degrees. When I drew this altitude, what it did is it cut this side right in half. Right, so half of 18 is 9. That's this side of my triangle. I want to know what's the height? What is this part? So, in a 30, 60, 90 triangle, let me put the ratio around the outside. Across from the 30-degree angle is our x. Across from the 60-degree angle is x times the square root of 3. And across from the right angle, our hypotenuse, is 2x. Use the side you know to solve for x. Nice and easy in this case. Here's the side I know. X is 9. Nothing we even need to solve for. I have x, so I want to know this side. Go back and plug x in. And the length of this side is 9 times the square root of 3. That's my height. So the area of my triangle, 1/2 base times height. My base is 18. My height is 9 square root of 3. Okay, these are what I need to subtract. The area of my sector is, if you multiply all of those pieces, 169.6 about. And if you multiply all of these pieces, you get about 140.3. I'm just rounding to the nearest tenth. In the end, I'm going to round to the nearest tenth as well. If we had really nice calculators, what we would do is type all of this into a parenthesis, put a subtraction sign, type all of this into a parenthesis, and you would get the most accurate answer. For our purposes, I'm fine if you round each of these, and then what we're going to do with it is subtract them. Right? The area of my whole sector minus the area of my triangle, that'll give me the area of this leftover piece, my sector. If we subtract that, we get 29.3. We were measuring in inches, so inches squared. Okay, moving on to another example of finding the area of a sector. What's the area of the shaded segment shown at the right? Round your answer to the nearest tenth. Again, what I need to know is the area of my sector. That'll be the measure of my arc. That is 90 degrees. Right? Here's a 90-degree angle. So that makes the measure of my arc also 90, because this is a central angle. Those two measurements are one and the same. So 90 over 360 times pi times my radius squared. My radius is 4. So 4 squared. We'll leave it at that for now. Then we're going to subtract off the area of my triangle. This piece. And that'll leave me left over the area of my sector. Area of my triangle is 1/2 base times the height. We have both of these in this case. These are both radii, so they're the same length. All radii are the same length. And you can think about it either way. Here's my base, here's my height. They form that right angle. Base and height are always perpendicular. So the area of my triangle is 1/2 the base times the height. Up here, if you multiply all this out, you get approximately 12.6. And if you multiply the area of my triangle out, you get exactly 8. We want to subtract the area of my triangle from the area of my sector to give me the area of my segment, this piece left over. If you subtract those, you get 4.6. And we were measuring in meters, so meters squared. Okay, 2 more examples to top things off. Find the area of the shaded region. It says leave your answers in terms of pi. I will do this for part A. For part B, it'll actually make sense to round. So we'll round to the nearest tenth. And this is also more accurate to what you would be asked to do on the test coming soon. So for part A, we will leave our answer in terms of pi. We're finding the area of a sector, a pizza slice. The area of a sector, I need to know the measure of my arc. In this case, they gave me the central angle again. The central angle and the measure of the arc are one and the same. So the area is 75 out of 360 degrees times pi times my radius squared. My radius is 9, so 9 squared. Leave answer in terms of pi means take pi, scoot him on down, don't do anything with pi, multiply everything else. So take 9 squared is 81, multiply that by 75, divide by 360, and we get 16.875. So the area of that sector is 16.875 pi inches squared. We're measuring in inches, so inches squared. Moving over to part B, finding the area of the shaded region. In this case, this is a sector of my circle. So we'll need to find, a segment. This is a segment of my circle. What we need is to know the area of the sector. The area of my sector, which would be the area of this whole region, this big pizza slice, will be the measure of my arc, which is 120, over 360, times pi, times my radius squared. My radius is 2, so 2 squared. We'll leave it there for now. And then we're going to subtract the area of this triangle. So we need to find the area of that triangle so we can subtract it and just have the area of my segment left over. That'll be 1/2 the base times the height. However, it's tough to find these in this case. I have a 120 degree arc right here, which makes my central angle in here also 120 degrees. So if I use this side as the base, my height, I don't really have a good way of finding the height of this triangle. So what we need to do in this case is imagine I draw a height here and I cut this into a couple right triangles. We can work with that to use this side as my base and this as my height. Here's why